But welcome back from the break. We're here now with our next speaker, MC Forelle. MC is an assistant professor of engineering and society at the University of Virginia's School of Engineering and Applied Science. They received their PhD in communication from the Annenberg School of Communication at University of Southern California before becoming a Presidential Postdoctoral Scholar at Cornell. So Cornell representing today. They are researching the US automotive industry's shift from hardware manufacturing to software development, particularly as those shifts impact the repair, maintenance, and modification of vehicles. And MC has been kind enough to stay up after dinner. So we're getting to the witching hour. But thank you so much for accommodating this time zone because we really wanted to have your input as we bring up these issues, and it's really over to you at this point. As long as you're ready to go, we're really looking forward to hearing you. Okay, thanks.
Awesome, thank you, and thank you to the organizers for having me. It truly has not been that much of a hardship. I have young children, and I'm sure those of you with young children know that like after 8 p.m. is like our time. So I'm really delighted to be joining everyone here and to be joining such an incredible collection of people who are whose work I've been following and I'm excited to share mine with. So let me begin. As Mel mentioned, I'm at the University of Virginia in the Department of Engineering and Society. So I'm in an STS department within a School of Engineering, which has been a very interesting place to be doing this work. I myself have a background in ethnography and policy analysis. So that's the approach that I'm taking to a lot of this work. It builds off of fieldwork I've been doing for about 5 years now with automotive mechanics, car hackers, and aftermarket parts developers, as well as just tracing various right to repair bills and regulatory approaches in the US and a bit in the European context. So with that in mind, I'm going to start in a place that I think is very obvious now, especially to an audience like this, which is simply to say that cars are now computers. And this is true of all cars right now. Pretty much any car manufactured in like 1995 or after has some kind of computer in it. This is true specifically in the US, but given the sort of manufacturing trends is now sort of universally true around the world, that there's some sort of computer in almost every car that drives in the world right now. And so these computers, depending on how new your car is, run at the very least things like electronic fuel injection. If you do not have a carburetor in your car, you have a computer in your car. But in really advanced vehicles right now are running all sorts of processes. So this is adaptive cruise control, automatic braking, the infotainment systems in cars. The last time I saw a statistic on this, it said that modern cars are running up to 100,000 lines of code. And that statistic is now a few years old, so you can imagine how much that's grown. But this isn't just a technical reality, but also a corporate one, right? As mentioned in my bio, this is something that I'm really focusing on, is the fact that a lot of automotive manufacturers, global automotive manufacturers, are saying out loud that they are no longer hardware manufacturers, but software developers. That quote specifically came from Hyundai. But you can see this happening sort of across the board in global auto manufacturers as they shift towards doing things like microchip manufacturing in-house. They are shifting from, instead of partnering with software developers, they are bringing software development in-house, right? And so this is really changing how the automotive industry, not only how it works, but how it sees itself, like what role it sees itself as playing and how even it functions. While this is happening, there are also things happening in policy and regulatory spaces that are really aiding and abetting, for lack of better words, this shift, right? And so there are things that are happening specifically in the push towards the ban on internal combustion engines and the setting of quotas for electric vehicles that is really encouraging the movement of the automotive industry into a tech and software development space. And so as you can see here, these are some headlines I pulled from basically the last year. In the US, we do not have a federal ban on internal combustion engines, but there are state level bans. And in the US, where California goes, especially when it comes to automotive regulation, so too does the country tend to go. The Biden administration recently released some like quotas, but they're extremely soft. There are more concerted movements happening in Europe. So very recently, EU lawmakers approved a ban on internal combustion engines for 2035. And similar things are beginning to happen in Australia, although it's a little bit more complicated in Australia. So in Australia, it's happening at the state or territory level, the same way it's happening in the US. But in Australia, interesting things are happening where there's a lot of the banks in your country are beginning to refuse to provide loans for cars that are have internal combustion engines that are gas-powered cars. And so even if it is not a federal policy, there are state-level policies and also business-level policies that are really pushing for this shift. So if we're seeing across these different spaces this move towards cars being software objects, the title for this talk was originally software enhanced vehicles. It is now software defined vehicles because the industry keeps changing what they want to call these things. But if this is the shift we're seeing, then what are the implications for repair, maintenance, and modification as we continue moving in this direction? One claim that commentators like to make is that actually this move towards electric vehicles and towards really computationally powered vehicles would be good for repair, in the sense that, like, because electric vehicle motors have fewer moving parts, they are less likely to require maintenance and would probably require fewer repairs. Now, this is an axiom that I had seen repeated in many places, but I hadn't been able to nail down where this claim is coming from. So for right now, I can only assume that it's speculative based on, basic principles that fewer parts to break means less breakage. I would love to find people who are doing like research on whether this is actually true, but I haven't found it yet. But assuming this actually is true, and a lot of people assume that it is, this is actually causing a great deal of friction for electric vehicle adoption. So in the United States, the way that car dealerships work is that they are like affiliated with, but technically independent from the manufacturers. And so for them, a lot of the money they make is in the space of repair and maintenance, because their garages are where a lot of car owners decide to bring their cars. And so because repair and maintenance are their bread and butter, it's the way they make a lot of their money, hearing that electric vehicles are going to require less repair and maintenance is actually pushing a lot of dealerships to refuse or resist selling EVs. And so this has been documented. This is a really interesting sort of part of the push and pull towards electric vehicles, at least in the American context. But is one of the ways that we see that, for all the advantages that electric vehicles purportedly have for repair, there are some like downstream consequences to that. The other problem that electric vehicles and software-defined vehicles in general, so not just electric, but including electric, pose to repair is the fact that they because they rely on software and because they rely on the microchips to run that software, they draw on different parts of the supply chain. So this is something that we saw perhaps most dramatically during the peak of the COVID pandemic, when the pandemic required that microchip foundries stop production. And as a consequence, the car factories also stopped production. And this caused incredible ripple effects globally in terms of the prices for both new cars and used cars. And so if this is the impact that a microchip shortage had on the manufacture of new cars, not a ton of research has been done about this. I'm beginning to dig into it, but my intuition is that we're seeing similar impacts on the ability to make repairs, right? So if you can't find the parts to make new cars, you probably aren't finding the parts to repair the cars that exist. And so the fact that we're building cars that run on microchips means that now this repair ecosystem is pulling from a different supply chain that has different vulnerabilities and different weaknesses, and different demands on it. If anyone's interested, I would love to get into more detail about the fact that cars require different kinds of microchips than most consumer electronics, and there was some friction in that as well. Yeah, so this is another place where software-defined vehicles are really creating some issues in terms of repair and how repair can and will get done. So this also creates problems like, okay, so say you can get the part, okay, or you think that you can get the part. Most software-defined vehicles run, like the software runs based on readings that it gets from sensors that are placed all over the car, right? And so these are all kinds of different sensors. This is long-range radar, short-range radar, medium-range radar, LiDAR, cameras, some limited ultrasound, things like that. And each of these requires a different kind of sensor that's taking different kinds of readings. So if you are at a repair shop and you get a car like this, that, it got into a fender bender, you remove the fender and then you need to repair the sensors that are along the fender. So this creates a couple of issues. One is that manufacturers are not super forthcoming with what kinds of sensors those are. And the fact that like each make, model, and each year, there are differences between model years, will use different kinds of sensors that need to be replaced in different spots. And especially for independent repair shops, getting the information about like the schematics for where, what kinds of sensors those are and where those sensors need to be placed is actually both very time intensive and costly. You have to pay for those schematics. There's an additional complication in that even within the same model year, depending on what factory that car was manufactured in or when it was manufactured, the factory may have used a different supplier for its sensors. So then repair shops may even need to go so far as to figure out like which supplier, like which sensor manufacturer was used for this particular car, which is again just like an enormous drain on time and energy for independent repair shops. Okay, so let's say you figure all of that out. Then your next problem is that you have to calibrate these sensors, right? So sensor calibration requires, again, depending on make, model, and model year, different sets of targets and different like space requirements. So for example, Honda specifies that recalibration for some of its models requires an open area that is 13 feet wide, 5 feet high, and extends at least 23 feet in front of the car. Lexus requires an open road at least 32 feet long and 45 feet wide in front of the car. So I'm living in Virginia right now, but before I lived in Virginia, I lived in Brooklyn. And my automotive repair shop was in the middle of Brooklyn, where a space 45 feet wide and 32 feet long in front of the car would cost an astronomical amount. Like local shops just do not have that kind of space. and do not have that kind of resources to get all these different targets and all these different like stripes and things like that. So recalibration, even if you can find the parts, even if you can figure out where the parts go, to even get those parts to speak to the car's central computer again through the process of recalibration is enormously difficult. The protocols for doing this are also extremely proprietary, takes a lot of digging to find them, takes a lot of money to pay for them. And so you can see how this is adding up, especially for independent repair shops. What's more, the technicians who do this work require additional training, many of them, and require ongoing training, because as these technologies advance, the skills required to do these repairs also advance. So a lot of manufacturers offer this kind of training, but again, it's an investment of both time and money. And there is some discussion, at least in the United States, although not as much discussion as I would like to see, about how to make sure that community colleges and trade schools, the places where a lot of our automotive technicians are being trained, are being kept up to date with all of these requirements, right? Like, how are we training the next generation of repair specialists? And how are we making sure that that training is up to date, so that they don't also, after getting that basic training, have to go and continue paying for ongoing education frequently, right? Because these technologies, because they're computerized, because they're computational, they advance very quickly. So this is a problem just within the repair ecosystem. In addition to all of those concerns, I'm just going to rattle off concerns. Like, this is a project that I have ongoing and I'm still trying to organize, but I just keep finding reasons to be worried about these things. The main focus of a lot of my previous research has been how the integration of software into automotive technologies has made them subject to different legal regimes. And so copyright in the United States is one of them. And even when we have made some gains in terms of copyright law, they have figured out how to do carve-outs. So I think, as Josh mentioned, software-enabled cars run a lot of subscriptions now. So you have to subscribe to heat warmers, you have to subscribe to remote start, you have to subscribe to high beams and to certain forms of torque and things like that. And the manufacturers have made sure that any service or any feature that is offered through subscription is exempt from the laws that protect the right to repair automotive technology. So you can still be sued for copyright infringement if you're trying to repair a feature that is offered through subscription. And then finally, my last concern that I would love to talk more about is about the longevity of these things. So cars, at least in the United States, are lasting longer on the road than they ever have, at least in the history of us recording how long the average age of the car on the road is. But the same is not true of things like smartphones and other consumer electronics, right? And so if we're turning our cars into things that are being designed by people who are whose background is in consumer electronics and who are like thinking in terms of tech, like car companies now think of themselves as tech companies. So does that mean that they are adopting tech companies' approach to obsolescence and to software support, right? And so we've seen this concern, this like the repercussions of this in other spaces. I'm particularly interested in like connected homes and domestic spaces. And so this was an example that created a lot of headlines, where Google acquired a company called Revolve. It was a connected home company, and then just bricked the product, right? So they just acquired a competitor and then bricked the product and stopped offering support for that product. And so is this a concern that we're going to see in the automotive space, where car companies are no longer, will not support the software after a certain amount of time, will not continue to make components available after a certain amount of time? So I think the road ahead, these are my concerns about electric vehicles and software-defined vehicles in general. Huge concern when it comes to like autonomous vehicles or whatever that's going to wind up being. But I think it extends into other places where we're trying to connect things. So connected homes, smart cities, things like that. And so my hope, my provocation is that we need more people who are doing research on, as we are pushing for these national level EV quotas and internal combustion engine bans, are policymakers thinking through how this is going to impact supply chains, or how this is going to impact investment in other forms of like mass transportation and environmentally sustainable transportation. Are we expecting electric vehicles to take on all the work that those other transportation alternatives should do? Definitely need more research on repair and maintenance training and engineering education for repair and maintenance. I don't see a ton of that happening, and I would love to see more of that in the space. And then finally, the electric vehicle life cycle, right? What can we expect in terms of long-term software support if electric vehicles are supposed to last minimum 10 years, but hopefully decades after that? How are we building these cars to last decades? And component availability, right? Like if these sensors are what these cars need to run, how long are they going to be available? And to what extent will the aftermarket be able to offer alternatives if the original manufacturer is no longer supporting that product? So a lot of concerns, not a ton of answers. Really, really interested to see what people want to talk about.
Thank you so much. I wanted to make sure you got some feedback because I know how tough it is to present remotely without interaction, but there were quite a few laughs as well as a lot of applause just then, MC. Thank you. We have a little bit of time for questions. I'm really delighted that you put this research agenda as your last slide, because one thing to explain to you as someone based elsewhere is that the research centre that's supporting this event is ongoing for the next few years, and so they are at a point where they'd like to include more sustainability questions in the agenda. So I hope that's putting some ideas in people's heads. So in the room, it looks like we have at least 1, 2, maybe 3 questions. I'm sounding like an auctioneer. So go ahead, Nick.
Thanks, MC. My name's Nick from University of Queensland, and I had this. You got me thinking about this. Okay, this is a very Australian way of saying it. I don't know if the thing I'm going to talk about is kind of bullshit, but so I'd appreciate your kind of view of it. But this idea that cars, particularly, the comment you made about car companies becoming tech companies, that one of the shifts we should anticipate in the business model is a move toward a subscription business model. So begin to think about the car as a subscription. So is that going to happen, or is that just industry chatter? And if that is what's going to happen, the subscription business model is something we're picking up from the tech sector, or that comes from the tech sector. And what is the relationship between a subscription-oriented business model and sustainability? Like, a subscription business model is generally a threat to sustainability, or can you think of sustainable versions of it?
Yeah. So short answer, it is happening. Car companies have been boasting about how the move towards a subscription model for features is going to be the way they make money in the future. So they want to be the next Netflix, but automotive manufacturers have never had margins the way Netflix has margins. So they want Netflix style margins. And the only way they can do that is by becoming a subscription thing. Whether or not it is good for sustainability, I want to be thoughtful about my answer to this, but I can't because it's not. I cannot think of a single argument. Automotive companies love to say, like, oh, it'll be great because then we could do over-the-air updates for your software and your car will always be as up-to-date. Like, it'll be like a new car every day because we can update its software. And I'm like, yeah, but the parts still wear out. So you're going to have new software running on an old car. It's like they forgot that the car is an actual physical thing that exists in the world, and like entropy doesn't exist anymore. So they're trying to sell it really hard. It is at least the short-term future of cars. My advice would be, if you're going to buy a new car, buy it soon, or keep your eye on the secondhand market.
Okay, that's great. Thank you for that response. We have many questions in the chat too, so I'm just going to run to one of those, if that's okay. Nathan, can you still speak, or can we read your... I might read your question in the interest of time, but it's
okay.
really...
Yeah, you can probably hear me, but...
Oh, you can? Yeah, go ahead. Why don't you ask it?
Yeah, well, first of all, best car repair presentation I've ever seen, and the people hired big-time PR firms to do this, and that was much better. I have this question about, and you seem to have some insight into car makers, but why are, like, basically all EVs like the luxury version of the line of cars, instead of, like, I have a Hyundai, the Elantra, there's not a lot of, you're hand cranking the windows. Like, why don't we see this with EVs? Every single EV seems to be like this, kind of has a video game aesthetic, and it's super complex. And I don't understand, from, like, if I was an EV maker, somebody's got to make that bottom of the line EV, right? Why doesn't that happen?
It's a business choice. The margins on the low, not low cost, but like low priced cars are nothing compared to the margins from the extremely gamified vehicle, because those gamified vehicles, because of the subscription model, the constant updates you can make to the software and to the way it runs, are just, they make you a forever customer, right? And so it's not just the one-time sale they get you forever, right? I think this really connects to the right to repair space and the battles that are happening in that space, in terms of, like, we don't want to go to an authorized dealer. We want to go to our independent, like, repair shop, because my relationship to you, the dealership, should be over now. My relationship to you, the manufacturer, should be over now, and I just want to go live my life with my device. But the manufacturer is not making money off of you that way, right? And so I don't know what's going to happen. Like, I'm also very curious to see what happens, because now the average price of a car in the United States is like over $47,000. There are very, very few models that are made for the consumer who's trying to buy something under $30,000 new. And I don't know how that is sustainable from a business perspective. But the brass seems to think that they can't squeeze any more money out of the stone that is the lower class, right? And so they're aiming for the people who can go in for those repeat payments.
Yeah, it's also reminding me of the previous discussion where we talked about over-engineering for the lead adopter of, for example, AI use cases, as opposed to someone who just hasn't been online yet. So the fact that cars are becoming computers is reinforcing those divides. I'm conscious of time. I think we'll take one more from the room and one more from the feed, and then the rest we can hopefully answer in the chat while you're still awake. Who has the mic in the room? Yeah, Peter, go for it.
Hi, my name's Peter. My question sits a little bit between the last two, and I know that not all SDVs are EVs, but there seems to be a kind of symbiotic relationship between the two. And what I was curious about was whether there are any, so I know from what you've just said, is that, that at scale, there's not really a market for doing this kind of low-end EV. But in terms of the fact that EVs are often sold on the kind of renewable energy sustainability positives from that, are there any EV makers that are actually kind of reducing the kind of SDV-ness of themselves in that kind of sustainability mode, or to that end?
Yeah, that's a good question. I wish I had an answer to it. I think in the American context, the answer is no. But I think this is where I could really use the help of the people in this room to take a more global approach, because I know that there are some European automakers that are still very committed to small sedans and small hatchbacks. This is certainly a case in countries where the roads just work differently, right? So I wonder if there are going to be more people in, like, like Indian automotive manufacturers, or certainly Chinese automotive manufacturers who might be exploring that space more. I'm not familiar with it yet, but I'd love to talk to someone who is.
Okay, and I was going to ask Sylvia to take the last question, just because it's an area we haven't touched on yet. Sylvia, are you able to talk, or would you like me to?
I am. Can you hear me?
Wonderful. Yes.
Excellent. MC, thank you so much for your talk. I recently actually leased an EV, and I've never leased a vehicle in my life before. But my viewpoint was that the battery technology would progress so rapidly that my car would be out of date in 2 years. So I have a 2-year lease. And that's my particular experience, but I'm wondering if you've thought about, especially in the next few years, what the lifespan of these EVs will actually be. And maybe this gets into, reuse, or what do we do with these batteries? Is there some kind of improvement pipeline that you see coming about?
Yeah, so this is where I think being based in an engineering school has given me a really unique perspective, because there's a lot of work right now happening to improve lithium batteries, or to pursue like alternatives, especially because the United States has found some lithium resources in the country. And so all of a sudden there's like a renewed interest in that here. So yes, I think battery technology will continue to progress, and at least on that front, EVs are going to have greater longevity. But I worry that is not the front where we're going to lose them. I think that the front where we're going to lose them is basically in software support. I just don't know if these manufacturers are going to make these cars either support the software for as long as these cars could be on the road, even like with improved batteries, or build the cars to be interoperable enough to support future versions of the software, or to like run lower versions of software, or to be available for like aftermarket operating systems once the like initial like operating system is no longer supported. Like I don't know that they're thinking on that time scale beyond battery life, and I think that's where we're going to lose them.
Okay, well, wonderful. And you will be hearing more about energy and battery life from Sylvia later in the Electronics Ecology series. She's a wonderful AI architect in her own right in California. So thanks for joining, Sylvia. Thanks, MC, for an incredible talk. Everyone's very excited about it. So if you're not awake as much as you may be in a talk environment, the energy in the room has been fantastic. So thank you so much, everyone, please.